So we care about net filtration pressure, the net pressure that is based on hydrostatic pressure and osmotic pressure, both in and outside of the capillary. Here's our capillary, a simplified section. It receives blood from our arteriole. There's the blood coming in, and blood is going to leave, going out the venule. So let's look at the pressures that exist in the different portions here. First of all, we're going to have hydrostatic pressure in the capillary. We're going to have hydrostatic pressure in the interstitial fluid. We're going to call this 0. It often is close to 0, very low. I'm going to write millimeters of mercury once to remind you that's the units. I'm not going to write it for all of these. I don't have room. Hydrostatic pressure in the capillary is 35. This can vary, but these are the numbers I'm going to use as an example. We then have osmotic pressure in the capillary. That's due to all that protein and red blood cells that can't leave, 25. And we're going to say osmotic pressure in the interstitial fluid is 0. Okay, I've got a lot of stuff in here. What's up with that? Well, let's look at what's going to move out and in. I'm going to do outs in pink. This hydrostatic pressure, this is a force out, right? Which way is our osmotic pressure? Let's draw this a little thicker here because it's 35. Osmotic pressure is higher inside the capillary than out, but that's going to mean its force is in. So let me do this. This is green. Our pink is hydrostatic pressure. What is the net filtration pressure at this location? It's blue and red. Net filtration pressure is the forces out minus the forces in. I tried to make this simple by having the 0 in this case. Forces out is 35 minus 25 for the forces in, 10 plus 10 millimeters of mercury. Plus 10, that means filtration occurs. The net pressure inside is positive, it's higher than it is outside. As we go down the tube, what changes? Well, hydrostatic pressure is going to change because we're losing, right? Pressure changes throughout circulation. We're slightly have reduced blood pressure as we continue through circulation. So here at the middle, hydrostatic pressure is going to be 25. So is osmotic pressure. This is going to be a net filtration pressure of 0 and no movement. Now, as we go further, same thing continues. Our blood pressure, hydrostatic pressure in the capillaries is going to decrease even more. Our osmotic pressure basically stays the same. We still have the same amount of stuff in there. That's still 25. I'm going to draw this one out again with my lovely arrows. So now our hydrostatic pressure out, I'm trying to draw a little bit smaller. It's less than our osmotic pressure, which is still the same. So this here was 25, this here is 25, but this was 35, this was 18. Arrows are not to scale how they should be. So what's our net filtration pressure here at the venous end? Forces out minus forces in equals minus 7 millimeters of mercury. What does that mean? The forces in are stronger. There is more force going in. So that's reabsorption. Net pressure is in. Over here, the net pressure was out. Beautiful, huh? Lovely. Let's do a learning check.